In this tutorial, we will see how to calculate the reorder point for the economic order quantity models. Note that this applies to the basic EOQ model, the production EOQ model, and the EOQ model with quantity discounts. There are four things that determine the reorder point. 1. The rate of demand. Naturally, the faster the rate of demand, the higher the reorder point. 2. The lead time. The lead time is the time it takes to receive an item once it is ordered. The longer the lead time, the higher the reorder point. 3. The variability of either the demand, lead time, or both. The higher the variability, the higher the reorder point. 4. The degree of stockout risk that management is willing to accept. A stockout is running out of inventory. The lower the risk of a stockout, the higher the reorder point. We will be looking at four different models. 1. Neither demand nor lead time is variable. This is the simplest model. It is a deterministic model. 2. Only demand is variable. In some textbooks, this is the only variable model that is covered. 3. Only lead time is variable. And 4. Both demand and lead time are variable. R is the reorder point. That is, the level of inventory at which a new order is placed. Some textbooks use ROP, which is short for reorder point. D is the demand rate and LT is the lead time. Both must be expressed in the same units of time. That is, if D is weekly demand, then LT must be stated in weeks. Days or weeks are the common units of time. SS is safety stock. That is the amount of inventory carried up and above average demand. Safety stock is carried to reduce the chance of a stockout. When neither demand nor lead time is variable, the reorder point is simply the demand times the lead time. This is best illustrated with an example. In this first example, weekly demand is 500 and the lead time is 2 weeks. There is no variability in either number. What should the reorder point be? The demand of 500 times the lead time of 2 weeks gives us a reorder point of 1,000. Now, here's an example for you to try. Weekly demand is 2,000 and the lead time is 1.5 weeks. There is no variability in either number. What should the reorder point be? Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. The demand of 2,000 times the lead time of 1.5 weeks gives us a reorder point of 3,000. When dealing with variable demand and/or lead time, we use z-values from the standard normal distribution. Since we can only have a stockout when demand is larger than average or lead time is longer than average, we are always using a one-tailed z-value. Specifically, we are always using a positive one-tailed z-value. The table on the slide shows common stockout risk values and their associated z-values. If only demand is variable, then the reorder point is the average demand during lead time times the lead time plus the z-value times the standard deviation of demand during lead time. Note that D bar is used in the formula rather than D. That is because demand is now variable and we must talk about average demand. The first part of the formula is the demand during lead time without variability. The second part of the formula is the safety stock and is added for when demand is higher than average. One complication is when the time period for the lead time and standard deviation are not the same. For example, the lead time is expressed in weeks and the standard deviation is expressed in days. The second formula on the slide shows how to make the conversion. That will be explored in the example that follows. In this example, a local garage uses an average of 200 cans of oil a day. Daily usage has a standard deviation of 6 cans. The manager is willing to accept no more than a 5% chance of a stockout, thus a 95% service level. Lead time is 7 days. Assuming the distribution of usage is normal, what is the reorder point? In this case, we have a daily standard deviation, so it must be converted to a lead time standard deviation. You can see that in the substitution in the formula. We plug in the 200 average daily demand, lead time of 7 days, resulting z-score of 1.645, and daily standard deviation of 6. Those calculations result in a reorder point of 1,426. Now, here's an example for you to try. A local company uses an average of 650 items a day. Daily usage has a standard deviation of 23. The manager is willing to accept no more than a 1% chance of a stockout, thus a 99% service level. Lead time is 14 days. Assuming the distribution of usage is normal, what is the reorder point? Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. Again, we must convert the daily standard deviation into a standard deviation during lead time. Plugging in the average daily demand of 650, lead time of 14, the z-score for a 99% service level of 2.326, and the daily standard deviation of 23 gives us a reorder point of 9,300. The formula on the slide is used when the daily demand is fixed, but the lead time is variable. The first part of the formula calculates the expected demand during an average lead time. The second part of the formula calculates the safety stock. Notice that the daily demand is used in the calculation of the safety stock. That is because the lead time is varying, and higher levels of lead time result in higher demand. In this example, daily demand is 200 and average lead time is 7 days with a standard deviation of 2. The company desires a 98% service level. Calculate the reorder point. Plugging in the daily demand of 200, average lead time of 7, the resulting z-score of 2.054, and the standard deviation of 2 yields a reorder point of 2,221. Now, here's an example for you to try. Daily demand is 850 and average lead time is 12 days with a standard deviation of 2.5. The company desires a 99% service level. Calculate the reorder point. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. Plugging in the daily demand of 850, average lead time of 12, the resulting z-score of 2.326, and the standard deviation of 2.5 yields a reorder point of 15,143. The formula on the slide is used when both demand and lead time are variable. In this example, a retailer is the sole distributor of a popular computer tablet in a mid-sized town. The demand for this tablet is normally distributed with a mean of 130 and a standard deviation of 12 tablets per day. Historical data indicates an average lead time of 6 days with a standard deviation of 1.5 days. What is the reorder point for a 98% service level? Plugging in the average daily demand of 130, the average lead time of 6, the resulting z-value of 2.054, the daily standard deviation of demand of 12, and the standard deviation of lead time of 1.5 yields a reorder point of 1,185. In this next example, a company orders an item with an average daily demand of 225 and a standard deviation of 8. It has a lead time of 22 days with a standard deviation of 4. They want a 99% service level. What's the reorder point? Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. Plugging in the average daily demand of 225 and its daily standard deviation of 8, the average lead time of 22 days and its standard deviation of 4, and the resulting z-value of 2.326 yields a reorder point of 7,045. If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.